Let's face it, our modern world is thirsty. It runs on a constant flow of energy. The fuel in our cars, the electricity that powers our lives. But what happens if that well starts to run dry? And that fear, that little bit of anxiety, is what's launched this epic quest for secret energy.
It's a question that, gives a lot of us anxiety, right? I mean, you see the prices at the pump go up and down like a roller coaster. You hear about conflicts over resources. It's only natural to wonder if we're on the edge of some big energy crisis. And that feeling, that vulnerability, that's really the engine behind this whole search.
So today, we're going to follow that quest, all the way from these kind of wild, fantastical theories buried deep inside our own planet to the actual, real-deal scientific missions that are prospecting our solar system for the fuels of the future.
So, here's the plan. First, we'll dig into why we're always searching. Then, we'll dive into the pretty wild theory of a hollow Earth. After that, we'll pivot to the real-life hunt for resources on other worlds. And finally, we'll pull it all together and figure out what this big search really says about us.
So what's really driving these incredible searches in the first place?
Well, it really boils down to one simple but really powerful idea: dependency.
Okay, so take a look at this number. For a country like Thailand, it represents a huge vulnerability. They have to import about 85% of their oil. Think about that. When any country is that dependent on foreign energy, their whole economy is basically at the mercy of global markets they just can't control. And that feeling, of powerlessness, that creates this really deep desire for some kind of secret, local, and, unlimited source of power.
And that desire, it's the perfect breeding ground for all sorts of myths and, let's be honest, conspiracy theories. I mean, the idea that there's some hidden miracle solution out there is way more comforting than dealing with the messy, complex reality of global energy. It even led some folks to believe the answer was, literally, right under their feet.
Yeah, forget looking to the stars, at least for now. The first theory we're going to explore suggests that an infinite power source isn't out there, but right here, right beneath our own feet.
So the core idea here is that our planet is kind of like a cosmic matryoshka doll. One of those Russian nesting dolls. A series of shells, one inside the other, with this huge livable space on the inside. It's a totally wild concept for sure, but it didn't just pop out of thin air. It actually has its roots in some pretty early scientific thinking.
So the history of this theory starts with a really serious scientist, Edmund Halley. Yep, the same guy the famous comet is named after. He was actually trying to solve a real mystery at the time, why compass readings were going haywire. So his idea of a multi-shelled Earth was a genuine attempt to explain it. But then, later thinkers kind of ran with the idea, adding things like inner suns, and eventually you had people like Marshall Gardner using things like flash-frozen mammoths as proof, arguing they must have wandered out of a warm, hollow Earth and into the freezing cold of Siberia.
Look, Halley's theory was a pretty creative solution for his time, right? He even used it to explain the northern lights as gas leaking out from the interior. But modern science gives us a much, much clearer picture. By studying how seismic waves from earthquakes travel through the planet, we know for a fact that it's solid. There are just no vast, hollow spaces down there. So, if the secret energy source isn't under our feet, well, that means we have to start looking up.
And that brings us out of the realm of myth and squarely into the world of real 21st century science. Because today's quest for energy, it has turned its gaze upward, to our neighbors in the solar system.
So, the target this time isn't some secret magical sun. Nope, it's something much more fundamental: hydrocarbons. We're talking about the basic carbon and hydrogen building blocks that make up fuels like methane. And as NASA's probes are zipping around the solar system, they're finding these things in some very interesting places.
Okay, so our first stop, Saturn's largest moon, Titan. And this isn't just some boring rock in space. This place is a whole world. It's got a thick atmosphere and, get this, actual seas and lakes made of liquid methane. It's basically a potential fuel depot on a scale that's hard to even imagine. But the challenges are just as huge. For methane to be a liquid, it's got to be around minus 160 degrees Celsius. And then there's the distance.
Just look at this. It really shows you the tyranny of distance. A trip to our moon takes a few days. Getting to Mars, that's the better part of a year. But a one-way ticket to Titan, you're looking at about 7 years.
the amount of energy you'd need just to get there would probably be way more than any fuel you could possibly bring back.
So a much more practical destination might be a little closer to home, Mars. The red planet is, well, it's a potential treasure trove. Rovers have found evidence of complex organic molecules. You know, the building blocks for life and for fuel. Its atmosphere is almost all CO2, and it's got huge amounts of water ice at its poles. It's a lonely place, though. The Curiosity rover famously sang happy birthday to itself, just once, before NASA figured it was a waste of precious power. But that whole power problem? That's exactly what scientists are trying to solve right now.
Okay, this is where it gets really, really clever. The concept is called in situ resource utilization, or ISRU. That's just a fancy way of saying living off the land. The plan is basically to land on Mars and then make your own rocket fuel for the trip back home. You'd mine the water ice, use solar panels to split the water into hydrogen and oxygen, and then you'd combine that hydrogen with all the CO2 from the Martian atmosphere to create methane. You can literally make your own return ticket right there on Mars.
And what about our closest neighbor, the Moon? Well, it turns out it's holding two incredible resources of its own. The first one is super practical for right now, water ice. It's locked away in these craters at the poles that haven't seen sunlight in billions of years. But the second resource, that one's for tomorrow. We're talking about helium-3. It's a really rare element that's been deposited by solar winds over eons, and it could be a powerful, clean fuel for the nuclear fusion reactors of the future.
So, after all this journeying to the center of the Earth, to the outer reaches of the solar system, what have we actually learned? What's the real takeaway from this grand quest for secret energy?
Well, the first lesson is pretty clear. There are no magic bullets. The hollow Earth is a fun story, but it's a myth. And while the solar system is packed with resources, getting to them is an incredibly complex, expensive, and long-term challenge. There is no easy fix.
And that leads to the second, and maybe more profound lesson. Science is a journey, not a destination. Think about it. Even the hollow Earth theory was born from a real desire to understand our world. It's the quest itself that pushes us forward. The idea that what we think we know today could be wrong tomorrow. Well, that's what makes new discoveries so exciting.
And so ultimately, this whole search for secret energy reveals that the most powerful, the most limitless resource, it isn't methane on Titan or helium-3 on the Moon. It's the human drive to ask questions, to imagine, to explore, and to solve problems. Our own curiosity and ingenuity, that's the real power source. It's been with us all along.
Which really leaves us with one final thought. We spend all this time and energy looking to the heavens for new homes and new fuels. But maybe the biggest lesson from this whole cosmic quest is to just look back at our own planet. After all this searching, maybe we'll finally realize that the most valuable, most precious world in the entire universe is the one we're already standing on.